All right, welcome back, everyone. Today we're going to talk about functions and function notation. In this lesson, we're going to talk about the definitions of a correspondence, a relation, and a function, the definition of the domain and range of a function, how to determine if a correspondence represents a function, or if a relation represents a function, how to determine the domain and range of a relation, how to use function notation, and then how to use function notation to locate points on a graph. So the first thing we need to know is what's a correspondence. A correspondence is any relationship between two sets, with the first set representing some input, also called the domain, and the second set representing the output, or also called the range. For example, if we look at the picture here, we can see that the appointing president would be the domain, and then the Supreme Court justice that they appointed would represent the range. Okay? These are correspondence between two sets of items. So what's a relation then? Well, a relation is a correspondence where the member of the domain corresponds to at least one member of the range. Right? So where each member of the domain corresponds to at least one member of the range. Okay? It's more than just a correspondence because all the members of the domain are used. The domain of a relation is the set of all possible inputs of the relation. So what are all the possible x values? Right? When you're dealing with ordered pairs, domains are just asking you what are all the possible x values. When you're looking for the range of a relation, that just means you're looking for all the possible y values. Okay? The range is all the set. The range is the set of all possible outputs of the relation. And so here we have a relation. It's just a set of ordered pairs. And we want to find the domain and range of the given relation. Well, the domain is just the set of all of the possible x values. All of the possible x values are -1, 3, +1, -3, and 8. That would be our domain for this relation. For the range is the set of all possible y values. So in this case, it would be 2, 5, 4, and 10. Notice that in the relation, 2 appears twice as a y value, but when we write the range, we only have to include it once. Okay, it's the list of all the possible y values. We don't have to include duplicates. So talking about correspondences and relations, we need to know now what's a function. Well, a function is just another correspondence, but it's between two sets, the domain and range. However, it's different from the other two because each member of the domain corresponds to exactly one member of the range. Okay. Different from a correspondence because all the members of the domain are used. And it's different from a relation because all the members of the domain are used only once. And this implies that every different input yields a different output. Okay? And here at the bottom, you see the same x value cannot give a different y value. Okay? That statement's very important when we're looking at sets of ordered pairs to determine if they represent functions. The same x value cannot give a different y value. So to determine if a correspondence or a relation represents a function, we have to determine that each member of the domain is used and that each member is only used once. So let's look at some previous examples and we'll determine if they're functions. The first example was the appointing president and the Supreme Court justices. Okay? Notice that this correspondence does not represent a function. Okay? We have 3 members of the domain that give more than one member of the range. So each of these presidents here appointed more than one judge. So their input produced more than one output. Their x value gave you 2 different y values, which means it's not a function. Now the second example we did, that was the set of ordered pairs. That relation does represent a function. Notice that each member of the domain, all of the x values are only used once, Okay? And they correspond to each member or some member of the range. Okay? The same x value does not give different y values. Okay? You should notice, however, that different x values can give the same y value. That's perfectly okay. You just can't have the same x give you a different y. So let's try another example. We want to find the domain and range of these given relations, then we want to determine if they represent a function. Well, for f, the domain is just the set of all the possible x values. So 1, 2, 3, and 6. And the range is the set of all the possible y values. 5, 15, 7, 8, and 9. Now we want to determine if this represents a function. Well, to determine if it represents a function, we need to see if the same x value gives us different y values. And if we look here, we have the point 1 and 5, and the point 1 and 8. There we have the same x value, 1, giving two different y values. So, for the first relation, this one's not a function. Now for g, we can do a similar thing. We want to find the domain. The domain is the set of all the possible x values. So that's going to be 3, 0, -1, -2, and 5. The range, 2, 9, 7, and 10. Now we want to determine if it's a function. So we just look to see if the same x value gives us a different y value. But none of the x values are the same. So there's no way for the same x value to give a different y value. And so this one is a function. So to determine the domain and range, the domain is just all the possible x values, the range is all the possible y values. And then to determine if it's a function, just look to see if x, or look to see if the same x value, as you see here, gives a different y value. If that's the case, then it's not a function. If that does not occur, then it is a function. So when we talk about functions, we need to start to talk about what's called function notation. Function notation is just a way to describe how the inputs of the domain correspond to the outputs of the range. Okay. The most common function that you're familiar with is a linear function, y equals mx plus b, and we're going to spend some time on that in the next few lessons. Okay. In this case, the domain, or the inputs, represented by the x value, and the range is represented by the y value. Very similar to what we just did when we were talking about relations. In function notation, all we do is replace y with this thing f of x, where f is said to be the function of the variable x. We usually read that f of x. Okay? F is the name of the function. Okay? So if we write a linear function in function notation, we write it like you see here, f of x is equal to mx plus b. So how do we use function notation? Well, function notation shows the relationship between the domain and the range. Okay? Given the function and an input, you can determine the respective output, okay, by just plugging in for x. And given the graph of a function, you can locate points to determine function values. Okay, so let's try some examples with both of those. Given the function g of x below, we want to determine g of -2. Well, our function g of x is x squared plus 3x minus 5. And we want to find g of -2. So what that means is we're just going to plug in -2 for x. and then solve. Negative 2 squared is positive 4, plus 3 times negative 2 is negative 6, minus 5. 4 plus negative 6 is negative 2, minus 5 is negative 7. So g of negative 2 is just negative 7. So our input here was negative 2. If we input negative 2 into this function, our output is negative 7. Now, we do not always have to input known variables or discrete values. Okay? We can also use a variable. So for example, we're given f of x is equal to 2x squared minus 5x plus 6. And we want to find f of x plus 2. Well, to find f of x plus 2, we're just going to plug in x plus 2 for x. So that's going to be 2 times x plus 2 squared minus 5 times x plus 2 plus 6. So just rewriting this, we get 2 times x plus 2 times x plus 2 minus 5 times x plus 2 plus 6. In this first term, when we multiply, we have to FOIL this thing. We should get 4 terms. FOIL the polynomials or the binomials first, and save the 2 for last. So this is 2 times x is x squared. X times 2 is plus 2x. 2 times x is plus 2x. And then 2 times 2 is 4. Minus, now we can distribute the 5. Give you minus 5x minus 10 plus 6. Remember that when we distribute the 5, the negative sign distributes with it. Now we can distribute the 2 after we simplify and make this 4x. So 2 times x squared is 2x squared. 2 times 4x is plus 8x. And 2 times 4 is plus 8. Minus 5x minus 10 plus 6. And now we just want to add all of our like terms and simplify. So that's 2x squared. 8x minus 5x is plus 3x. And then 8 minus 10 plus 6. 8 minus 10 is negative 2. Plus 6 is positive 4. And that would be your answer. The most important thing to remember when dealing with a problem like this is that when you get to the x plus 2 squared part, it's important that you remember to FOIL that, just like we did here. Okay? If you don't FOIL that, when you multiply, you'll get the wrong answer every time. Now finally, let's talk about locating points on a graph given the function notation. Okay? What we're going to do is we're going to use the x values to locate the points. Okay? And remember that the function value is just given by the y value. Okay? So starting with this graph to the right, we want to find h of 1. Okay? Well, 1 is the x value. So we're going to go to where 1 is. We're going to look at the function. And we're going to say if x equals 1, then what's the y value? Well, in this case, if x equals 1, the y value is negative 2. And we would do the same for the other points. For h of 2, we're just going to look where x equals 2. And when x equals 2, the function is equal to 1. And finally, h of 5, we're going to look at where x equals 5, and the function value is just negative 2. So the x value is given to you in the parentheses, and then you look to the graph to determine the y value. Okay. So at the end of this lesson, you should be able to explain the difference between a correspondence, a relation, and a function. Determine whether a correspondence or a relation represents a function. Determine the domain and range of a given relation. Use function notation to determine the values of functions given x values. And use function notation to locate points on a graph.